Oh, darn it.
So a few years ago, I bought this rather nice little AA aluminum flashlight. It was to replace my mag light, and my mag lights kept burning out and getting corroded inside. Lucky me. And I kind of like this one because it has the button at the back which turns it on, and oh look, there he goes. The batteries are getting low, and which is much more handy than having to twist the mag light on, which I found to always twist in my pocket when I was working. One shortfall of this is that if you do this, it does come on, and I do throw that into my ditty bag, and it lands like that. So I don't like that idea too much. The other thing is that if you push it, it simply rolls away. Now, one of the first things I did when I got my 3D printer was to make a guard for this, which is this little piece here, and also stop it from rolling. So you can see there's a bit of an indentation in here, and there's actually a lip to stop it from sliding all the way onto the flashlight. So you see the hexagonal shape and the lip inside. There you are. And you put this on like so, and if you drop it, nothing happens, and it doesn't roll away. There you go. So that's great. Now, I've got 2 flashlights. I'd like to make those 2 things. We'll start with this one, which is directly comparable to the to this one, this little guy. It's aluminum, has the button at the back. No batteries in it right now. There's a acid leak. So yeah, now it does have this, it's circular and it has these little indentations on the ends, 5 of them. I guess that's supposed to stop from rolling, but it doesn't stop it from rolling. And it's very frustrating. So, I'm going to have to do that. So, this is going to have, like this one, it's going to be a lip to stop it from sliding on, just like this. We'll have a hole at the back, so you get like there. And then I will have to make some adjustments, so something in here to hold on to the to grip on there as well, where the indentations are. Now, got that one, but since I'm here, I thought I would do this one, which is another flashlight. It does have a thing here which will stop it from rolling. So we do this. Hey, it's nice. Do that though. It's a long flashlight. So it's a bit frustrating. Again, now, what I'm going to do is this will be another extrusion. It'll be a simpler version of this. We'll start making with this one. Because all I got to do, take that off. And like that. Just slide something on, and then that cap will hold it on. That's my idea. So it's going to be 2 simple designs in Fusion 360. So this will be the simpler one, and this one will be a little more complicated. So we'll do this one first, and then that one. All right. So what have I got? Well, I made an actual design this time. It's pretty good. So we'll start with this one, the Garrity, which is this flashlight. It's a simple extrusion, so it's going to be really simple. It's going to be a hexagonal shape and a circle. And look at that. It's just on the side profile, a rectangle. So super simple. The Duracell, which is this one, that one, we get your hexagon and your circle, but there'll be a lip inside as well. And on top of that, I'm putting these little circular extrusions. There'll be 5 of them by the time I'm through. Will help provide a little extra grip and also compensate for the divots that are in here. There you go. That's a divot there. So, yeah, we're going to see how that works. All right. So working in Fusion 360, I started with the end cap for the Garrity D-cell flashlight. In sketch mode, I created a circle, 43 millimeters in diameter. I then created a circumscribed hexagon. That's measured from the center of the hexagon to the middle of one of the sides. And I had to remember to put that distance in as opposed to the whole width. Otherwise, I ended up with a hexagon twice the size I wanted. And that defines the outer edge of the end cap. Now, before I went too far, I saved the file. To create the 3D object, I selected the shape defined on the outside by the hexagon and on the inside by the circle. So I ended up with this hollow hexagon. Then I selected the extrude function, and then I typed in the final length of 20 millimeters. Then I finished off the object by chamfering the inner edge, in other words, putting an angle in there. And then I added a round fillet to the outer edges, so when you print it out, it had this nice, smooth, finished feeling to it. And that's it, the end cap for the Garrity flashlight. And it only took me 6 minutes to design. The Duracell End Cap started off the same way as the Garrity. In sketch mode, I drew a circle that was the same diameter as the barrel of the flashlight. And then a smaller one to define the lip that goes around the base of the flashlight. Then I created the hexagon that defines the outer edge of the piece. And now the next step, I created a pentagon to define the location of the embedded columns that will press against the recessed portions of the barrel. This is an inscribed polygon, so the size here is determined by the distance from the center of the object to one of the vertices. And then I drew a circle 4 millimeters in diameter at each vertex of the pentagon. So now I have the sketch done. Then I had to select those parts of the sketch to be extruded. And since there are several intersecting shapes here, I had to be more careful in making my selections. I decided at first to extrude the lip, but I changed my mind. So what I did was I extruded the main body first. And I wrapped it up by filleting and chamfering the edges, just like the other one. Although it took me a bit longer because it's a more complicated shape and I had to figure out exactly what I wanted to do. And then off to the printer. So let's see the results of our labors. This is the one for the Garrity T, which is this light here. And it's okay. It's not bad. I'm not a huge fan of it. It doesn't feel that good, but it's great. I mean, it does work. The problem, of course, being is this. Just a little big. And that's me. That is me. I have this thing where I will add and subtract numbers randomly when I take measurements. I wouldn't say it's dyslexia, but it's something like it. I have a record of kind of things that happen. It's too short. All right. Now for this one, which I've already tested, we have this. And in here we see the nodules, the extrusions that are supposed to fit in here. So these are supposed to fit there. And what's happened is that I put this in. Actually, it actually goes on now. I've done it 2 times and it's actually quite loose. But actually, you can see it's not going on properly. There. And it's like that. There's also a really, if you can see it, focus. Really hard from this angle to see. There you go. Yeah, I'll get my thumb away. There's a big gap there around the main body of the flashlight. And that's, I don't know. When I did the measurements, there we go. It does grind away at these, which is a bit frustrating. So I don't like that at all. So what we're going to do is I've made some adjustments. The Garrity one, I simply made sure the diameter is the right size. Oops. And for the Duracell one, again, I've had to change the diameters and some numbers over here. And you can see my scrawl over here as I work some numbers out. But I am going to drop this circular stud part and I think just use another circular extrusion. It'll be a bit different. So let's see how that works. So now we're back at the drawing board again to fix my errors from the last time. Redoing the Garrity end cap was quite easy. All I had to do really was to change the diameter of the inner circle to 38.5 millimeters. It's a bit of an odd dimension, but I discovered that in fact that the barrel of the Garrity flashlight flared out a little bit at the very end where the cap screws in. This is like 0.5 millimeter off. But done really quickly, and then I finished it off, and presto, it's pretty much the same as before. For the Duracell end cap, or maybe the anti-roll end cap could be a better name for it, I decided to replace the round embedded pillars with ones that were segments of a circle. It just made it a nicer shape. So in sketch mode, I created 3 circles. One for the outside of the barrel, or the inside of the cap. One that defined the lip at the very end, so a smaller diameter circle. And then a third one of intermediate diameter, which defines the flutes, which is what I'm calling them now, that go into the recesses on the barrel. I then drew a rectangle, which would define the actual width of each one. And then I duplicated that around the center of the circle 4 times. And then finally in the sketch, I created the hexagon for the outer edge. Now, I had to then extrude this, and it was a bit easier to grab all the shapes than the previous version. However, I noticed that I had these little bits of the rectangle sticking outside of the hexagon. So I had to deselect those. That was a bit finicky, but worth it because it made things look better. And so once I did the extrusions, I finished the edges, and that was it. Just looking at this version, I like it a lot more than my first version. And then it was off to the printer. So we're going to do the final review, and that is for the Garrity, and that one is for the Duracell. And I'll do the Garrity first. Now, I'm going to say something. I actually did the Garrity twice. This is that one is its final print, and it's much better than that one. I changed the settings, 2mm thick walls, and a 25% infill. This is a 1mm thick wall or something, and a 15% infill. And the difference is amazing. This just feels solid. Whereas that, you can actually, if I put it in the microphone, you hear it. So it's not very strong. So we'll get rid of that one. And we're going to do the big reveal on this. So here we go. And I hope that's in focus. Oh, look at that. That's perfect. Can I screw this on? Oh, awesome. Here we go. Look at that. Nice. Hey, perfect. It works. Now for the Duracell. So we have the Duracell, and I have the Duracell thing. So let's see. As you can see here, if I put that like that, with the bevels of the new fill-in for that part there. And then you have the lip on the end that stops them sliding on. So let's see if this is going to work. I have rehearsed this time. So we'll put that like that. There we go. Okay. It's a bit tight, but yeah. A little more. There, perfect. Aha. So yeah, it's nice. It's just nice and fits nice. And yeah, there you go. And it's not going to roll away. In fact, that's so good. Stop. That's so good. I made two. So there you go. I think this is pretty good, despite my efforts of messing it up. So yeah, that's it. There you go.